All right. Hello, everybody. Hello, Twitch. Hello, YouTube. Hello, everybody listening on the streams. Welcome to today's session about GraalVM and Ruby. Let's talk about Ruby. GraalVM is much more than just Java.
Right.
Hello, everybody.
Hello, Twitch. Hello, YouTube. Hello, everybody listening on the streams.
It is
welcome to today's session about.
Yeah, sorry about the audio hiccup. It was a little bit of a of a loop here, of a metacircular loop, which is by the way also very on point because GraalVM is very metacircular. But yeah, no, GraalVM is not just Java. GraalVM is also about other languages. And last week we talked about Python, and this week I'm excited to talk about Ruby. And I have here as my guest on the screen Benoit today, who is the lead for TruffleRuby, and who will drive today's session with showing the current status of TruffleRuby and also how the open source community of TruffleRuby works, etc. And yeah, no, Benoit, take it away. Like, what is Ruby on GraalVM? Like, what's the point of running Ruby on GraalVM?
Right. So the point of GraalVM Ruby or TruffleRuby is basically like to be the fastest Ruby implementation. And basically it's the only Ruby implementation like with a JIT that really understands Ruby code. Like all the other JIT that basically have so many limitations that they might understand maybe half or not even that of the semantics. They cannot inline to the core library and so on. So let's maybe take a look at the website page here. So we recently got a website here as part of the GraalVM website. It says high performance Ruby, and well, yes, and the main benefit is indeed running Ruby faster. And then something that's unusual for like an alternative Ruby implementation is that it also supports C extension. So basically C extension, like the regular one from an engine, basically just work on TruffleRuby for most of them. That's really a unique feature. Right? It means like basically it's almost a drop-in replacement for C Ruby.
Right, and so the C extensions, they are like supported because we emulate here the Ruby MRI interfaces, right?
Right, yes, and then we all do this with the GraalVM LLVM interpreter, so we have much more flexibility there. We can also like kind of optimize them together, and later we'll see like how they kind of like everything is kind of the same. So you can have another backtrace with C files in it, which is something that you would normally never see on C Ruby. You can even debug into that code.
Right. Right, and then there is, of course, because it is like it can run in the context of a JVM if you want, right? So you can have sort of this interoperability with Java and also other languages.
Right, yeah, well, it's on GraalVM, right? So you can interact with all GraalVM languages. That's pretty cool.
Right.
I think we still have some work to do there to make it more intuitive, but we have some great ideas. Like basically the idea is like whether it would be a Python list or R vector, it will still look like a Ruby array, and you could call like each map, I don't know, select, flat map, whatever you want on it. And it would just actually if it was a Ruby array, basically. So it would all be transparent, and then you could like basically access other ecosystem, right? So like Python is well known for like machine learning and AI, and there's not so much about that in the Ruby space, but you could just use these libraries. And also like Python is such a close language to Ruby, it would be pretty natural to call it from Ruby.
Right.
So that's kind of nice.
Yeah, but you can kind of run this, like, can I already today like run Python from Ruby, or like, but the interfaces might still need some polishing.
Yeah, you can already do this, and yeah, the basics for us basically we just want to make it a bit nicer. Right. But for now, like if you can call any method on any Python object, and because that's the way you would access an API, so that already works transparently.
Cool.
And then yeah, so we want very high compatibility with the standard Ruby, C Ruby, so we can be a drop-in replacement. And we can also execute Ruby code in parallel. We don't have a global interpreter lock. There's just no need for it. So that's also a big advantage for instance, a web server.
Right, and uncompatibility, this is, I think, the hardest part on the project, right? Because it is a from-scratch implementation. So we really put, like, the largest part of our effort is kind of making sure it's compatible.
Right, so Ruby has probably like one of the languages with the biggest core library with so many methods and classes.
Right.
And basically all these methods are either defined in Ruby itself for TruffleRuby, It's a bit easier to maintain, but still, like Ruby doesn't implement those in Ruby. They implement everything in C. So we kind of want to maintain that part of it, and also the rest is basically implemented in Java for us, for the core library. And of course, like Ruby, like there's always a new Ruby version once per year, and we have to update to it and like implement the new built-ins and whatnot. So that's also always ongoing work, but I think we have a pretty good story there. We actually like basically, yeah, if we switch to something else, we can see like here a comparison of implementation. So CRuby, standard Ruby pass 100% of the test because the test must pass on CRuby, that's the rule. And then on TruffleRuby, overall, we have 97%, which is really good. And if you look at GraalVM, it's like 88, and like other implementations, much less than that.
Right. And so these are the tests that are used for CRuby. Can you go back a little bit to the tests again?
Yes,
so these are about here 30,000 total spec tests, right?
Right.
And those tests sort of encapsulate the Ruby specification.
Yeah, except there's nothing official about Ruby specification, but yeah, this is the closest probably you can get.
Right.
So like this is a suite of tests that's maintained basically by multiple Ruby implementation to make them compatible. There's also another suite, which is the suite of MRI tests. There's not so many details, but I think I have a number below it.
All right.
I think we run about half of them, which is already very impressive because those MRI tests is a lot of corner case, and some of them is like MRI doesn't stack fault, and we're like, well, it doesn't apply for us usually.
Right. Okay. Yeah. Okay, makes sense. Cool. And so now if I want to use TruffleRuby and I have a like, do you have anywhere like something where you say, oh, these are the modules that are supported, or like, how do I know if my app runs on TruffleRuby? We should just try it.
Yes, we just try it.
Right.
So like people often ask, does Rails work on TruffleRuby? And the answer is just yes, it works. Like you use Rails 6 or more, it just works.
Right.
And then there might be some corner case in your app or some gem that has a problem, but like basically you have to try it because like, yeah, that's the simplest way to know.
Sure. And then after when I have a bug or something, and I would report that at the Truffle open source GitHub pages, right? Because TruffleRuby is an open source project. I think it's a million lines of code almost that's maintained here open source for TruffleRuby on GitHub. And here, I guess I can on the issues I can report issues.
Yeah, I can just report an issue here
if I'm running into something where a corner case is not accurately handled.
We also like accept two kind of bug reports. Like one of them would be like, okay, yeah, something doesn't work as Ruby. Like typically that's a bug. We want to behave exactly the same for as much as makes sense, which is almost everything. And we also accept performance bug report, right? So like if you find a TruffleRuby is slower on something, basically that's also a bug and we want to fix that.
Right. Yeah, because on the performance side, I guess it's similar where like there could be a corner case where performance is worse, and this could dominate your application, right? This is the general problem on this performance side. If you're good on 90% of the cases, you still need to be okay on the rest of the 10% of the cases.
Yeah, exactly. So there's so many like core methods and so on and things in Ruby that kind of needs to be fast for the whole app to be fast, and it's easy to have one bottleneck that kind of brings everything down. Right. That's easy to see with a profiler if it's really a big one. But it could also be a lot of small ones that are slightly slower, and then it's also something to solve and to work on.
Cool.
Right.
All right, yes. And then there's some tooling, etc., that's different, I guess, from the standard Ruby, because there's some additional tooling available, right? Like GraalVM, for example, which is a Java heap profiler that you can, with GraalVM, use also for Ruby, right?
Right. Yeah. So yeah, basically it's a lot of tooling in GraalVM that's independent of the language and that just works across the languages. And all of this is built into GraalVM. You don't need to install anything. It's just there. But in comparison, in Ruby, nothing is built in, right? So if you want a profiler, you have to install a gem. And if you want a code coverage, like some of it is built in, but it's not usable directly and so on, right?
Right.
So you can have a lot of extra tools that just work because that's how like all Truffle languages benefit from it. They just have to do a little bit of work on their side, and basically all this tooling just works from that.
Cool.
Okay, what do you want to talk about next?
Well, I guess you have performance benchmarks here a little bit down on the...
Kind of a bit of a teaser.
Yes. So
we say that the main goal is TruffleRuby is to be faster, right? So we want to show that, obviously.
Yes.
So there's the OPT carrot benchmark, which was like basically the main benchmark for this effort called Ruby 3x3, which was to basically try to make Ruby 3 three times faster than Ruby 2. And on that benchmark, it's actually achieved with the JIT, because Ruby 2 is something like, I guess, a bit below 30 here, and like that 85. But if you look at TruffleRuby, it's just like another order. Like it's not the same league, basically. Like we are like 8 times faster and 4 times faster than the baseline of 3.0.
Right.
So like we're more than tricks over the tricks to start with, right?
Right. And here basically TruffleRuby is both the last bar and the second last bar, right? Because there's two versions of TruffleRuby. There is a community edition version and something that is compiled with the GraalVM Enterprise edition, right?
Right. Yes, of course.
And I guess this is but as one can see here, already the community edition, which is fully open source and freely available, is here the fastest Ruby implementation out there for the opt-carrot benchmark.
Right. And then we have this Rubicon benchmark, which is actually an AI for the Go, the board game, Japanese board game. And that's been the benchmark existed for a little longer. And we've always been good at this, but like I think the last result also pretty impressive here. Like other implementation reach something like 2.3 times faster. We are like 10x faster.
Right.
And that's like for like I think for really like compute intensive benchmark, it's absolutely not rare to see that TruffleRuby is 10 times faster or even more.
Yeah, and those things, they're not micro benchmarks. They're of course benchmarks, but it's not micro benchmarks. I guess this is real Ruby programs.
There's already much bigger stuff already, yes.
Yeah.
But then of course there's more real world stuff. We'll go to that later.
Okay.
Yeah.
Right.
So
yeah,
maybe we should.
I think the bottom line here, and this is our mission here, sort of in the Ruby community, is like we want to make all of Ruby, like all of the constructs of Ruby, without compromise fast, right? And we want to allow people to use the language they love and get the performance without having to compromise on language features or anything else, because we try to be 100% compatible and at the same time fast.
Right. Exactly. Yeah, so maybe we should do a little demo about OPT carrot. I think this one is well known, but still it can be a fun one.
Okay.
Okay, let's turn a little bit bigger. So we'll take Ruby 3.0 here, 3.0.1. Did you see that?
Yes.
Okay, and then I can launch OPT carrot like this. I remove the audio because we on purpose don't make it run at 60 FPS. And if I run it on Ruby 3, so this is without the JIT, but like basically the way everyone would run the Ruby app today, you can see it goes at 30 frames per second. But this is a NES simulator. It's supposed to run at 60 frames per second, so that's not very good. So if we start the game, we see it's a little bit laggy, right? And like if I move around, basically I don't know on which shell I am anymore because there's so much lag, right? So I can try to play one level here, but it's not fun.
All right.
Okay, so this is like 33 FPS. Yeah, we also have it on the terminal here. And then we can run it with mjit, which like mjit is actually pretty good on this benchmark. On other benchmark, unfortunately, it doesn't seem to perform that well. So here it does reach the 60 FPS, but about it.
Okay, so this is the Ruby with the JIT option, yes.
Right. So this is decent, right? At least now it's playable. But we can do better than that, right? So if we run now on TruffleRuby, yes. So here I run GVM mode. There's also a native mode.
And you use here this Ruby selector, this change ch Ruby command. Is that your custom command to change the Ruby version?
No, it's standard, right? The only customization is it prints it below for convenience.
Okay, cool.
Standard. Yeah, so you can also install while you're at it. Maybe I can show that. I think it's here. No, sorry. It's here. So you can just install TruffleRuby with your favorite Ruby installer or Ruby manager. And then any of them just works. And super easy. It's even faster than CRuby because the only thing everything is already pre-built. The only thing you need to compile is the OpenSSL extension. Then you're good to go. So that's really convenient.
Cool. Okay, that gets me fast started, yes.
Right, so let's try this time of the carrot on TruffleRuby. It takes a little bit longer to start up. Yes, here we go. And there is some warm-up, right? So this is interesting. Like as soon as you have a good just-in-time compiler, it will take some time until it gets really fast. And here, like we were 60, now we reach like 170, 180. There's some zoom overhead, but seems reasonable here. And then, yeah, you see, like I changed what it does, and then it was surprised, but no, it re-optimized, and it's getting good again.
Right, this is the nature of the cheat compiler here, that it will have to know the code that is warmed up to get to the 200.
No, basically learned it, and we're like around 200 FPS or 170, almost constant. There's still, of course, some GC and stuff.
Right, 200, 250 I see as well, yeah. But it always depends if a new code pass is taken, but after a while the app is loaded and warmed up, and then it's just flashing. Got it.
So I should let you play that game. That would be more fun to watch.
Yes, that would be very embarrassing.
Okay, that sounds wrong. What did I do?
I'm not accurate. Okay. I'm not accurate.
How do I fix this?
It's too fast.
5 seconds or something.
I see. All right.
No.
Game over. Game over. All right.
Game over. To turn the last computer.
Yeah, cool. But so this is a relatively compute intensive like Ruby app, right? So the question, of course, everybody asks is like, what's your like Rails performance, right? Like, what's your performance on Ruby on Rails on like a web server?
Right. So I recently runs Railbench, which is actually from technically comes from Ruby originally, and then Kokubun from this Ruby made a fork of it, and then the Widget people Shopify also did that. Anyway, I'm running this version, Widget version, and so I ran it earlier here because I don't want to run this on the stream, so I have a bit more stable number. And this is on Ruby 2.73 because that's just the version TruffleRuby is compatible with, so we compare things a bit closer.
And what does this Rails bench do? It is...
Right, let me get that. Yes, okay, so the number here, so we see them is like 2.4, 2.5 seconds per iteration. And so we can see what it does in the harness because very simple. It's like this here. Yeah.
I see. So it creates a new Rails application. Has a couple of routes. Okay. We see the code nicely. Yes.
Yes. So what it does is basically it does 1,000 requests here, and basically it takes a sample of among the possible routes. And the possible routes here is like either the list of posts. Basically, it's a blog, right? A list of posts. There's also a JSON version of it, and then there's the first 100 posts, right? And then it just takes 2,000 out of that. And then one iteration is just going through these 2,000 requests, making sure that they're all successful.
Right.
So pretty simple, and it's actually single-threaded, so it's really easy to understand as advantage of this benchmark. It's really like how long does a request take, and then we have a computation later to show you in milliseconds. Yeah, so if we go to MRI, we saw earlier, yeah, something like 2.5 seconds for 2,000 requests. And then if we go to TruffleRuby, initially it's actually slower, right? Because it needs some warm-up as well. But then it gets much better to a point like it gets here to 800-900 milliseconds.
Cool. So that's also for a Rails application here, like 3 times faster.
Yeah. So this is 2.9 times faster. So basically we just need to divide by 2 when we have the time per request. So on MRI it would be 1.25 milliseconds per request, and here we do 0.43 milliseconds per request. So it's like a 3x increase, and I didn't change anything here. I just did bundle install when the benchmark done, right?
Cool.
That's also a benchmark we didn't really optimize for. I think the only thing we did was to change something about GC stats, which was a very obvious bottleneck. But other than that, we didn't like optimize it further. So I think there's also more potential. Right. Yeah. Something else maybe we can mention is also, I think it's quite known by now, like we're also collaborating with Shopify. Like there's a team there led by Chris Seaton, which was working on TruffleRuby at Oracle and moved to Shopify. And he's leading a team there. Basically, it's also like a second TruffleRuby team. and they're working on kind of like adopting TruffleRuby there and like making it work for their use case.
Yes, exactly. Like Chris was the founder of TruffleRuby, and he's now at Shopify and helping there and still contributing a lot to TruffleRuby nowadays. We're very happy about that. Also very happy that Kevin Benoit recently joined as well on the Shopify side to help us even more, and also other contributors. I think there's many contributors from Shopify now on TruffleRuby, right? Like I guess if you go to the GitHub page to our pull requests, we should see.
Yeah, it should be good.
We should see a lot of contributions there.
Yeah, so I think there's more than like easily more than 100 PR by Shopify here. Like basically, yeah, you see them, right? Shopify here, like, yeah, it's a lot of them.
Right.
You can go 4 page later.
Right, cool. Yeah, and that's very important because, I mean, Shopify has maybe the largest Ruby code base there is. And that really helps us now also with compatibility and running like a real app and getting really like this technology to be used in practice.
Right, so the Shopify TruffleRuby team was also super helpful. Like when we updated to 2.7, like they wanted to run their app onto 7, and then like we put our effort together, and like I think in a month we basically upgraded from 2.6 to 2.7, and like over 90% of it was basically ready. So that's really fast, I think, for a version update like this for Ruby.
Cool, yeah, and so that's in general like a shout out to the Ruby open source community. Like this is a community-driven open source project, and so we certainly are interested in both bug reports and compatibility from the open source community, as well as then also fixes or changes. And I mean, it's not that hard to hack on TruffleRuby. You don't need to be like a compiler expert to do it, because it's based on the Truffle GraalVM system. So, and I think in TruffleRuby, it's even like a lot of the library is written in Ruby itself, right?
Right, maybe we can show that for a minute as well. Except, yeah, here I have my editor. Okay, so for instance, oops, do you see that? Yeah, okay. Yeah, it's not very big, sorry for that. But so for instance, here I have some random file in RubyGems, and I can just click on thing, right, because the editor supports it. Okay, that's not surprising. Except that, of course, like here I have access to a whole core library and so on, so I have more Ruby source that you would normally see. But then if I go to, let's say, yeah, if I want to see, like, for instance, string gsub, which is like global search replace for a string, I want to say, oh, is that implemented, right? I can just go to it and say, like, here, this is core library. And then I have the whole logic here. Most of it is in Ruby, but some of it is in Java. And like, how does this work, right? How does the Ruby call the Java? And this is also very nicely done in terms of development here. For instance, here we say we set the last match. So there's like a special variable that's set in the caller in Ruby, like with the result of the regex match.
Right.
And then we can see here it's called primitive. It's a bit like the Smalltalk primitive. So basically, here's a nice integration because you can just click on it, and there's a magic comment that tells us we are to the Java code implemented.
Oh, wow. And you can even jump to the Java code here, right? Yes.
Right. So that's a pretty cool trick here. But in general, yeah, it's basically a lot of logic in Ruby, and then we call to the stuff in Java for things that kind of need to be in Java, right, or are much more efficient in Java.
Right. But like some of the stuff that in MRI is written in C++, right, is already written in Ruby for us, right? Because of
in C for them, not C++.
In C, right? Yeah, because they needed to do it in C for performance reasons, I guess, in many cases. And for us, the Ruby code is so fast that we can also in the core library write a lot of Ruby.
Right. I think Ruby was basically kind of mostly concerned that like if they write any kind of amount of Ruby on startup, they would slow down startup so much.
Right.
But here we don't really have that problem. We'll see a bit later why. And here, for instance, there's this integer time method, which is very well known in Ruby because you can do something like 2 times, and then you can say put set a world, right?
Yes. I see, and that's implemented
in IRB if I want, but yeah, it's not super interesting.
Right, and that's that's not implemented in Ruby. If you go back,
right, to this, you see, right, and then sorry, wrong one. Here we go. So this is the time method, right?
Right.
And then we see, okay, it returns something which is an enumerator if there's no block, but then otherwise it's just like the whole logic's in Ruby here. And there's an extra advantage that we can actually compile this with on-stack replacement, which means like if this loops goes on forever, but it's only called once.
Right.
It would actually compile the loop itself, right? Even though we never exit the method, or only at the end of the application.
Right. Yes, and so the Ruby version we are talking about here is Ruby 3.2.7. 2.7. Okay. But we're currently not supporting Ruby 3. Or what's our plan with respect to Ruby 3 and above?
Right. So we plan to update it to Ruby 3.0 relatively soon. We're kind of waiting to synchronize with that on Shopify because, of course, we want them to be able to run their app still with TruffleRuby. And Ruby 3 is a little bit incompatible with 2.7, so it's not something you can easily do. In the 2.7 and so on version, they were more compatible, I would say, but in 3.0, there's this keyword argument changes, which means you cannot just switch from one to the other unless you address the deprecation, the warning, and so on, right?
Right. Okay, cool.
Yeah. So maybe, so I'm mentioning something a little bit about startup earlier. The main concern for MRI, like if they write more code in Ruby, is that it would slow down startup. And this is something kind of we addressed, right? Because initially we were running on GraalVM, and the GraalVM is not particularly good reputation for startup. Right. It takes like a half a second just for hello world, which is in Ruby land, it's forever. So it's something we kind of addressed over time here within the GraalVM project. And so the end result of
because we are using here GraalVM native image actually to create the Ruby executable. So when we say here TruffleRuby native, it means it's the TruffleRuby Java application being compiled to native with native image. Because GraalVM native image is sort of original, actually. It was meant primarily to compile GraalVM's components that are all written in Java to native code for better startup.
Right, exactly. And then, so we see here with TruffleRuby native, which is actually the default mode, you get a startup of 25 milliseconds, which is really good. Like it's actually better than CRuby, which is about 50 milliseconds for the measurement. And the other implementation is slower. And then, of course, on GVM, it's much slower as well. I think now it's a little bit better. But the GVM is basically a different trade-off. It's like, oh, this is going to be a long-running process. I don't care that much about startup. Of course, we also care a little bit about it. But if you want the best startup, typically you would want to go native. Right.
But and if you want to have serverless
but if it's server that runs for days, then if it takes an extra second to start up or even an extra minute, maybe it's not that big a deal.
Right. Because also for us, if you run TruffleRuby on GVM, your peak performance will be better, right?
So peak performance usually is usually a bit better on GVM. That's true.
Right. So there is a small difference there in terms of also TruffleRuby native is going to start up faster, but peak performance will be a little bit worse than on
there's a bit of there's
GVM.
a table here that kind of compares them exactly, which is what we just said right now, I think.
Yeah, it makes sense. No, Java. One line here that we didn't talk about here is the Java host interoperability. So if you want to use Ruby with Java or Java libraries from Ruby, then we also pretty much recommend running this --GVM because it needs less configuration.
Yeah, it's a bit easier, but you can also do it on native if you want. Like if you know, okay, no, it's kind of what you want to do. Okay, you need this config for this project and this project, and you can also do it. And so the way we did this is by using native image, and there's multiple stuff over this. Like by using native image, I think we got down to something like 100 milliseconds. But then another thing which is pretty magical is basically we can take anything from the Java heap, but also the Ruby heap, because Ruby object is Java object in this context, and just store it in this native image, right? Store it in a way that ends up in this final executable that native image produces. And so we can actually here store the whole core library, the whole Ruby, the whole AST, everything we need to execute this core library we saw earlier, like this time methods. It's already in the image, already in the binary. So whenever we load the binary, it's there immediately. Just need to read it from there, and that's it.
Right. We kind of can snapshot. Yeah, we can snapshot that state out, and that gives us here on the very small applications a startup advantage, right? But if you load a lot of Ruby code, we'll still have quite some warm up, as was also shown in your benchmark with opt-caret.
Right. So this is to clarify. This is basically VM startup, the startup for TruffleRuby itself to start. but doesn't count for application startup, which is how long the application itself will need until it like handles the first request or something.
Right. Yeah, and there like we will be slower because we need to interpret this, we need to profile this, and we need to JIT compile it, which are all expensive operations that only gonna pay off if the application runs for quite some time.
Long enough. Yeah, exactly. So like the better the JIT, the more information it needs. So to get an idea of the level of information we have, like every branch in a if in a Ruby code, we know if it was taken or not. Yeah, like if there's a loop, we know how many times it was actually executed, things like that. So very detailed information there to really compile very well. But that also means like while we gather this information, it has some cost as well. So while we stay in the interpreter, it's typically slower than Ruby because we actually gather this information. But this kind of like, there's this warm-up phase, right? Where like increasingly better. So here we could see like that was some time ago, but like that's on a PT carrot. We start pretty low here with the blue point, but then it gets much higher soon enough, right?
Right. Yeah, and basically how many seconds it takes for the warm-up depends on how big your application is, meaning how much Ruby code, how many lines of code of Ruby your application is executing.
Right, yes. And like during startup, like Ruby application do a lot of crazy things. Like they don't just define classes, which would be an easy job. They like tend to, I don't know, load a giant YAML file or something like this. Right. Which actually like, okay, now we need to warm up all this extension code and so on, or we need to like, if it could also be written in Ruby, but then we need to load that to compile and warm up that Ruby code. Right.
And because the C extensions, they are also first interpreted before they are compiled, right? They are run with with GraalVM's Solong implementation.
Right. Yes, exactly.
Cool.
So actually, when we install a C extension, we have our own kind of toolchain. This is basically based on LLVM, but the only specificity there is basically it compiles to native, but also to bitcode. And actually, this is the bitcode that's what we're actually going to use to execute, and this gives us more flexibility. For instance, like we can have a struct in C, but actually maybe all of that struct is managed, right? This struct actually never goes native. Yeah, maybe you can a little bit of a look at that later.
Cool.
Yeah, a bit back to more real-world benchmark. So yeah, I was mentioning a bit the collaboration with Shopify, and like currently they're working basically on middlewares for the store form renderer. They made a blog post about that, I think, somewhat recently. And like there are quite a few middlewares there, and basically they turn these middlewares into benchmark, right? They turn a few benchmark per middleware because of different paths, like, oh, this is the exception, this is the no exception path, and so on. And overall, like if we use like MRI as the baseline, basically on TruffleRuby, they got speed up of like 3.6x on the community edition and like 5x on the enterprise edition. Which I think is quite impressive because it's real world code and like it does a lot of weird things, like for instance, throwing exception and whatnot.
All right, this is a real world, one of the most complicated Ruby code bases at Shopify for their sophisticated system, and no, I mean that's not just some benchmark. So yeah, so you say 3 to 5x is approximately what we get over standard MRI.
Yeah, over those middlewares, yeah, that's pretty good. And now they're going to look at the kind of like the app as a whole and see what we get there. Cool. And for comparison, like MJIT on this, only that's like 1.1x, so it only gives 10% extra, so it's not really significant.
Cool. No, this is really good numbers. Cool.
Right. What should we do next?
All right. So yes, we actually have a quote here from Chris, I guess, on the website.
Yeah. But yeah.
Yes. Okay. That's the quote related to the Shopify. Yeah. Okay.
Yes.
Cool. Excellent. We'll let our. Yeah. Cool. So I see. Yeah. So you see, there's examples here on the website.
Things we can try here, which is kind of a cool example about like interoperability in this case.
Right. On the left, we see there's some C extension that's just working. On the right, we see interoperability with the Java integer array. Right?
Yeah, exactly.
So you can create an integer array. Yeah, I would actually be interested in interop with a Python NumPy array, but I guess that's Yeah, that's
a try, but we need a bit of setup, like we need to install.
Yeah, all right. That we reserve that for a future stream. That will be the next stream.
Might need a Fortran compiler or some other weird thing.
Yeah, so that we'll reserve it for a future stream, the interoperability with NumPy. But yeah, okay, cool. And then yes, here we see then also some of this truffle tooling like CPU sampler, etc.
Right.
Cool. Yeah. Can we run this opt-caret stuff with the CPU sampler on? Maybe is that possible?
Yeah, I can do that. Yeah. Let's see. Yeah, we can just do
to showcase that there is other tools here that you can use just when you use.
And we'll just run it in benchmark mode because we don't want interface in that case. I think just for simplicity.
Sampler, yes, CPU sampler.
Exactly right.
Okay.
And this is already shows TruffleRuby here.
All right.
It doesn't do much output in benchmark mode.
Right. And how long does it take? How long does it take?
I think it's not very long.
Okay.
It should come soon.
Cool. Yeah, this just showcase. Oh yeah, cool. Yeah, already. This showcases one of the tools that you get for free when you use your TruffleRuby.
Right.
One of
you
the
just drop the
tools.
flag and you have a good sampler here. And actually there are upcoming improvements to it, but it's already pretty good. So here you say, okay, all the time it's spent in CPU run, which is like emulating the Nest CPU. It's like not too surprising.
Right. Or fiber resume. What is fiber resume here?
So that's the way the benchmarks return basically with two coroutines, and so they're called fiber and Ruby. And one of them is imitating the GPU, and the other one is the CPU, right? And so this is the CPU thread, and then whenever it resumes, you mean, oh, I'm waiting for the for the PPU or the GPU emulation thing.
Right. And fiber resume,
which is then I think below.
Fiber resume is a library method, right? Fiber resume is a library method here. Yeah, fiber yield.
Yes. Yeah, and this one you see is the other side of it, and then this one is just the actual rendering, like this PPU, which is but the pixel rendering unit, let's say.
Got it. So we have fiber yielding and resuming most of the time. So those are the library methods, I guess, or
yeah, they're called library.
And so this brings actually an interesting thing here is that I think one of the TruffleRuby team members is also active in the context of Project Loom of the GVM, right?
Right, Duncan from TruffleRuby team is also contributing to the Loom project, which is Loom project is like a project for the GVM to have much better support for coroutine. Because right now we emulate them with threads, just like JRuby does, because there's not really other options. But yeah, with Loom, basically you would be able to spawn some, like, I don't know, 10,000s of coroutines, and you would be able to switch much faster.
Right. So what
can be important for like IO workloads and so on.
Right. But in this benchmark, would it gain in this benchmark here or not?
Probably would gain a bit, but I think not that much because it's not that frequent to switch here. But still, like I gain something. We need to measure. Really.
Right. But for if you want to have a lot of so we are working with Loom and the Java world to get here coroutines like fast switching and lightweight threading. We will support it for the Java-based workloads of GraalVM, of course, but we will also take advantage of this in the context of our other languages like Ruby here.
Right, so here's a Rails app. You see immediately like there's a million more methods called.
Oh, yes. That's
by the sampler. So if we go to the main thread, I need to scroll so much. There. Yes, okay. There.
Okay.
One more here. Yeah, okay. So we see like in this Rails benchmark that there's a current state. We see, actually, most of the time
we are all logging, of course. It's
a bit sad.
Most web apps spend most of the time logging. That's normal, I think.
And then we spend, actually, this thing we looked earlier, like in GSOP, which is Global Search Replace. Apparently there we can maybe squeeze a bit more, or like we have to see a bit why is it used so heavily.
Right. Self-time 2.5 seconds. Actually, yeah, this is this also shows that the quality of this benchmark actually is higher than the other one, because in the other benchmark, we saw like 1 or 2 methods that took almost all of the time. But here, the top 2 methods only take 2.5 and 2.9% of the time, which shows that the breadth, the width of the benchmark in terms of having many methods that are important is much, much larger here.
Yeah, which means also much harder to optimize.
Yes, but which also means that the good results on these benchmarks are much more valuable. So cool, but
we have more Logger stuff.
Logger stuff add.
And this one we're working on already. Okay. So kind of like how to optimize the monitor standard library.
Right. But there's a long tail of things here. That's really cool. Yeah, cool stuff. But what is on this gsub? What is this gsub thing? Like, how is this? Can you show this in the standard library? This.
Yeah. I don't know. This doesn't work, but I can do this. Yeah, just like really global search replace. So you can say, I don't know. Well, maybe you can do it like this, right?
I see. So it's a string replacement is the main.
Right. Yes, I can replace all the A with I don't know E and.
Got it. Yes. Hello, GraalVM. Exactly. Then, but like, how is this gsub implemented for us? Is it in Ruby or in Java immediately?
Yeah. We saw it earlier. It was briefly. Yeah. It's in Ruby. Yes. But
I
there's
see.
actually
So
a lot
this
of
is
steps
this
to
one
it,
here,
right? So there's gsub, and then we actually have a replacement. So gsub internal.
Right, and then we go
and then
somewhere.
The other one, and then there's this other one. Here you get into the actual regex matching, which, by the way, we're starting to optimize now, because now we actually also have another language, another Truffle language, which is Truffle Regex.
Right.
For a while,
yes.
but now it's getting integrated with Ruby, and everything starting to see good results there.
Cool. So you are not yet on it, right? Are you already using Truffle Regex or?
Not in these benchmark results. It's not the default yet. We're going to switch that when case-insensitive support, which is worked on, is being worked on.
Cool.
Yes, when that's measured, we'll switch on.
There's Truffle Regex, which is another Truffle project, where we make a general-purpose regular expression engine. It was primarily first used by the JavaScript implementation of GraalVM, but now we're expanding this to other languages like Ruby here, and this will give us a boost because in JavaScript actually we are now faster than V8 on the regular expression benchmark of Octane in many instances, with this specialized regular expression engine developed by Josef Haider. And so this is really again shows one of the benefits of the GraalVM platform as well, because we are developing like one regular expression engine, and that one we are reusing across languages and JavaScript.
Right, also using Python and so on. Yeah.
Right.
Something like really recent work. You can see 3 days ago here, and the title of the issue was slower with Truffle Regex, which is obviously a bug.
Yes.
So something we worked on, and now actually it works properly, and actually the results are crazy, right? Because this is very simple regex. That's the disclaimer. But like the speed up towards the Ruby is like 27, 27, 40, 43, 41.
All right.
So this is, I think, quite unique in the Ruby landscape.
Right.
Maybe also in the Python. I don't know as much. I think JavaScript, they were used to a faster regex engine. In Ruby, everyone had a backtracking regex engine. Everyone was based on only grammar, and that's like not fast. And here, so first, it's not using that. It's using like this kind of state machine stuff that's much more efficient.
Right.
And also, we can just compile it and integrate it with like the code, right? Because there's the GraalVM compiler, it can see through everything, right? So it can compile through Ruby code, through regular expression, through LLVM bit code, whatever, right?
Right.
And so here we really optimized through all of that.
Cool. Yeah. No, I mean this and regular expressions are used quite heavily, obviously also in Rails applications.
Right. So in Ruby, you can do 10 million match per second. In TruffleRuby, you can do 400 million.
Right. Yeah, that's cool. That's really cool, and I'm very happy here, sort of from the GraalVM project perspective, how one of the components can here help out Ruby and be connected with Ruby.
What have we talked about yet? Startup already mentioned. Here we are at some point. I did here this small blog post was like a lot of very small script. Like I don't know, we can take a random one. Here it's really just a small problem, right? It's this advent of code for people that know. And I run all of them basically on MRI. It takes 105 seconds. On TruffleRuby, it takes 40 seconds, right? So this is like, okay, this is like where we have good VM startup. We can actually be faster than Ruby even on small scripts.
Yeah, that's just 40. That's just 1 minute script, and we are already faster. Good.
And this, of course, possible with native image, right? Otherwise, would be totally
with JVM mode.
Untrackable.
But is this starting?
I didn't bother to benchmark Ruby here because it would be pointless, right? To take 1 second startup everywhere, like no use.
Right, because this is starting this whole thing 25 times. Or how often is it starting this thing?
Yeah, of course, like
25 times. Okay. Once per
benchmark. They also take like 40 milliseconds, right? Some of them need to be.
Right.
If your startup takes that much, like oops.
Cool. Yeah, and yeah, so there's even some that are substantially faster here, half a second.
Right, all
versus...
the green stuff, yes.
Yeah,
like,
okay.
Significantly faster.
Cool.
Yeah.
So on the tooling part, I guess on the website we have also some description of the tooling, or how do I get that?
Right. So there's a pretty good description. I found like this page on the website. You go to GraalVM as a platform, Truffle language implementation framework, profiling, Truffle interpreter. Actually, yes, it's actually from a developer perspective, but it's also works just fine for a user perspective.
Right, and we can even get a flame graph. Can you go to the flame graph thingy? That's interesting, maybe. The CPU sampler, right. You can get a flame graph here. Is it?
Yeah, basically CPU sampler, you can just say, oh, output some JSON, and then you can get some script I did at some point, and then you basically get a flame graph. We're trying to make this easier, so you don't even need the script.
Yeah, exactly. We should ship the script and the GraalVM distribution.
Surprisingly, like doing a frame graph is not as simple as one would think, because like this SVG doesn't really scale well if you have so many methods, like in the Rails benchmark.
Right.
So now you need some kind of other frame graph viewer, but we'll get there.
Right. Okay. Cool.
Yeah.
Yeah, and so can I also debug this Ruby code, or how does the debug integration work?
Is it maybe let's show a bit of this interrupting. There's a very small example here, but nothing. Yes, this is fine. So that's what you don't normally see on the presentation is exception, but here we actually want to look at the exception. So I'm trying to query typo.rubigem.org, which obviously doesn't exist, and I get an exception. Oh, surprise! But the interesting part here is like, okay, so we go like, fail to open TCP connection because this domain doesn't exist, of course, right? But what we can look at, wait, we don't see this one. Okay, normally what you see is basically it tries to go through the OpenSSL library, right? And then you would see some C file. Let me see, why do we...
Here I see only Ruby code, yes, there's no...
Yeah, that's surprising. So that's from... Yeah, okay.
Also only Ruby code, yes.
Yeah, but that's from TruffleRuby, right? So this one was expected. Okay, for some reason it doesn't even get there here. It's too... okay, I see. Wow. That's putting it. Sorry about that.
Right. So the stack traces are mostly the same, but I see some slight differences somewhere down in the first few lines.
Right, exactly. So here we see some of the core library here, for instance. Yeah. Okay. Yeah, I think it doesn't even get to the OpenSSL part because it just like it fails.
Yeah, it fails earlier probably. Yeah, we would need something that fails in the OpenSSL.
Yeah, and this will then will just work. So then we won't. I don't think we'll see anything.
Right. Right. But maybe you just describe this. So we run OpenSSL in terms of native code there, and then we would see here potentially a reference to the native code if the exception happens there.
Right. Maybe we can do something else. So this zlib example, I think it's going to be a little bit easier. So I use this inspect flag, which is basically to launch the debugger here. Then gets me a URL I need to open in Chrome.
Is this something that only works for TruffleRuby, or is this also a thing in general Ruby?
Yeah, it's for general of the GraalVM platform, right?
But I mean Ruby MRI, you also debug in Chrome DevTools, so you can.
No, you cannot, right? So typically on MRI, you rarely have a visual debugger. Maybe the only one is for RubyMine or IntelliJ.
Okay.
And here is just part of the Truffle framework, right?
Right.
Okay, why does it not cooperate with me today? Okay, that's strange.
That's a bug report. That's good.
Okay, let's launch it from here, maybe.
All right.
I think it's the demo effect.
Of course. You wanted to show an exception, but not this one.
It worked, but... Okay, that's strange. Did I change my example? No, I didn't change my example. Okay, I don't know. Must be something with the network setup.
All right. So this Chrome DevTool debugging is our standard, or we also have another debugging available? Can I also debug with Visual Studio Code somehow?
Yeah, we should be able to do that. I don't have the setup done yet here.
Okay.
Yeah.
All right.
Yeah. Sorry about the demo here. I think you can see there's a talk from Kevin Mena about this stuff.
Okay. There's a talk on YouTube from Kevin.
Yeah. Kevin Mena. Debugger, I think that should hopefully, yes, should hopefully find it right.
I see, got it. Okay, yeah, cool.
Yeah, I can do that with this. Yeah, okay, now we start, like, this is the debugger basically, right? And we can see both, yes, for instance, the C extension we need and so on.
Right.
Yeah, you see here when it's C code, and then just above we have Ruby code and so on.
All right, cool.
All right.
Cool.
Yeah.
Yes. Okay. Cool. That was a good overview of where we currently are with TruffleRuby. So, what's the current focus for the project? Are you still working on getting more MRI tests passed, or are you mostly focused on warm-up performance at the moment, or?
Yeah, we're mostly focusing on performance at the moment because compatibility is just kind of good enough for most things we care about.
Okay.
There's still like one C extension we're kind of working that doesn't work yet, kind of cooperating there with the Solong team. It's quite tricky, but making progress. Yeah, performance we want to like kind of make warm-up really good, and of course peak good as well for large application, which is more challenging as they have so many more methods that need to be fast enough.
Right. Yeah, and on the warm-up side of things, one item that's currently under development but not yet finished is this ahead-of-time compilation for Ruby code, right? How would that work?
Yeah, sorry, just one more thing. Like this is actually the exception I wanted to show, but for some reason it didn't work. So here you can see in the backtrace you have like the osl.c, so you have the C extension and the Ruby code above.
Okay.
Must be just probably a configurational proxy or something, I guess. Yeah, so back to warm-up. Yeah, so one of the things we really want kind of like, yeah, we're working on as well is this auxiliary image caching or engine caching. So the idea is you kind of like, you would have some kind of AOT compilation, but like you can't AOT compile Ruby to like meaningful machine code, like to really optimize machine code. What you really need is a profiling run first. So you will run your application once, and then the second time, basically you pick up this GTID code from disk and then just use it, so it doesn't have to recompile it. Everything's already there and ready. So this needs quite a bit of implementation effort in Ruby, but we're making progress towards that. So recently we changed, like for instance, all the method and constant lookup and invalidation work, and this is really cool. Like for instance, like this, yeah, we don't support yet this AOT stuff, but already just with that, for instance, we don't have any invalidation anymore now when we run, like for instance, we run this. We start this Shopify storefront renderer app. Well, before we would have 1,000 invalidation. And the reason is like in Ruby, methods are already defined one by one. And so you get things defined extremely late. Like for instance, we go in Rails, and then you have this hash slice method, which is used a lot, which basically is just, oh, you have a hash, and then you say, I want this key, and the rest remove it. And like this is cool, but like this gets defined after 1 million files are loaded, right? And it's a method on hash, which is a core class, right?
Right.
So the typical approach, which basically I think all the Ruby VMs do, is like, oh, I have a version number, something per class, and then whenever I have a new method, I would invalidate that, and all other methods called on that class for all the call sites seen so far. Right. But here we have something that's like per class and per name. So basically, you would only invalidate if someone called hash slice before, which is not really. Is very unlikely because that would throw a method error, right? You would need to have two versions of the method for that to be like not an error.
Right.
Yeah, so I think that's a good step towards that. Like we want to kind of like make the code basically to be not dependent to a specific execution, but to actually be able to be reused in the next process as well. There's some documentation about that, I think, on the on the GraalVM website or on GitHub. Maybe it's easier to find.
Okay.
Yeah, on GraalVM website.
Yeah, cool.
Here. Yeah, so for now it works for JavaScript, and I think there's other effort also in the other languages as well to get that done.
Cool. All right, cool. Excellent. Do we have any other questions on Twitch or YouTube? I see on YouTube a few comments. One comment, yeah, from Ivan Slater. Ruby 3 in TruffleRuby, question mark. So this goes again back to this Ruby versions. Currently it's 2.7, right? But you do have plans for Ruby 3, but I guess it's not like what's the approximate timeline you would expect Ruby 3 to be supporting?
Yeah, I don't know. We really need kind of like any Shopify and potentially like other big companies to migrate to Ruby 3, and it seems didn't happen yet. And until then, like it's kind of hard because like we could migrate, but we'll just make ourselves incompatible by being too forward.
Yeah.
We also don't want to be too much behind, so I would think like hopefully before 3.1 goes out, because we don't want to be too version behind.
Right. Yeah, makes sense. But
also, I think it's not a really big effort, right? Like this keyword argument thing, which is we kind of already approach a bit into 7, and then the rest of the stuff is kind of minor. Some of the new features is something that cannot be added like as they are needed. They don't need to be exactly there immediately.
Right, but supporting both is kind of not possible. Like supporting both simultaneously is too much work in the code base.
Right, we've seen that from experience. Like when Ruby or Rubinius tried that, they just that almost meant the death of the project. Like they slowed down so much because they had to maintain 2 different versions and so that nightmare. So like we don't do that. What we do instead is like a bit more flexible with, like we say, for instance, oh, you want some Ruby 3 method, it's not incompatible with 2.7. Okay, let's just add it. That works, no problem.
Okay.
Yeah.
Okay. But in general, the timeline basically depends on how fast the Ruby library ecosystem
gets actually adopted in production, right?
Gets adopted in production for 3 because you want to be close to what is used in production here.
Yeah, exactly.
Makes sense. Cool. Yeah, we also have a question here on YouTube related to the opt-caret benchmark. Can I replace something in opt-caret with a Python list or a Java array list and it would still be fast?
Yeah, it should work. Yeah, you can try that. There's actually an instruction to run opt-caret. It's on the TruffleRuby repo. I think it's, I have it here, right? It's in .user opt-caret. It tells you how to run a demo I did today. And then you can just modify opt-caret to do that, and it should work fine.
Cool. Yeah, comment on Twitch, Neomatrix, sorry a bit late, but I hope I didn't miss much. Oh, you missed a lot. You missed a lot, but yes, you can catch up on that. You can catch up on that with the recording, which you'll put on Twitch and on YouTube, of course, as usual. And as usual as well, like if you have follow-up questions or anything, any comments, we have the GraalVM Slack channel, community Slack channel, where you can directly Slack Benoit if you have a question on TruffleRuby, or you can Slack me there. And so this way you can, if you have later have some follow-up questions here, talk again to us. Now, yes, cool. Thanks, Neomatrix, and thanks for joining us still again today. It's cool. And yeah, with this, we are at the end of the stream today. Thank you, Benoit, for this great overview of TruffleRuby and where the project is currently standing. I'm looking forward to more content on TruffleRuby moving forward, both as we get sort of large-scale apps into production, and also I'm very interested in the Ruby Python machine learning synergies that would showcase one of the benefits of the GraalVM platform as a polyglot system. We had something around that last week with Python plus Java interoperability. I think it could be very interesting to try as well, Python plus Ruby here.
Yeah, I think that should be very nice. There's actually a project from students that kind of integrated this PyCall RB library. Wasn't totally done, but like was already a good step there. And yeah, I think we want to keep improving on the polyglot stuff, make it nice and easy.
The current status here, I'm just showing it, is like, basically like you should try TruffleRuby if you want a better performance. And if it's not faster, just tell us or get in touch if it's, I don't know, you have any trouble. You can't really run many things. So the best way is to just try it. And yeah.
Right, and we have some migration guides here, migration guide from MRI, migration guide from JRuby.
Right.
So if you wanna port an application,
you can check compatibility, but basically compatibility says like everything should work except fork. But yes, you cannot fork processes. That is one true limitation.
Forking processes is a limitation, but otherwise it should work by default. And if it doesn't work, give us a bug report on GitHub or a Slack message, so we can look into the issue. And yeah, no, I think this is. Thanks very much, Benoit, for this status on TruffleRuby. I know now like where this currently stands, and looking forward to more in the future. Thanks everybody for listening on who joined us today and who gave some comments on YouTube or Twitch. And we will be streaming again next week, Tuesday. It will be again a GraalVM stream, and this time it will be about code analysis tools in the polyglot world. So we will talk about analysis tools polyglot with GraalVM, because GraalVM is a polyglot, and yeah, and it's a huge project. So it's meaning like many different languages are supported there, and we will talk about code analysis there on Tuesday on Oleg's stream. Oleg's Twitch stream, and as well as on our YouTube channel, youtube.com/GraalVM, where we now streaming our content as well. Cool. Thank you very much, everybody. Thank you, Benoit, for the content, and thanks everybody. Have a great rest of the day and the rest of the week.